Hello students. So in this lecture we will be solving few very good questions that I have collected from many books of DFT. For previous year questions of DFT you can go through the channel and you will find a playlist of previous year signals and system questions. So there you can do the DFT previous year questions very easily. Okay. So in this question it is given that xn is real. Okay. And it's a 12-point DFT. One more thing that you can easily prove here is that, yeah, I will not prove it, I'm just telling you, you can prove it easily. Okay, so when xn is real, then and xk is n point DFT, then x0 is real because we know that in that case x0 will be summation. Okay, I will prove it here also, here only. N equals to 0 to capital N minus 1 xn. So it's simply the summation of all the values of xn, that is x0. Okay, now if n is even, okay, so this is always true, but if in case n is even, then x of n by 2 will also be real because x of n by 2 will be n equals to 0 to n minus 1 xn xn e to power minus j 2 pi by capital N n by 2 n, that is n equals to 0 to n minus 1 xn e to power minus j pi n. Okay, so here we can see that it is actually equal to n equal to 0 to n minus 1 xn minus 1 to power n. So here also we can see that x of n by 2 will be real. So if xn is real and n is odd, then only x0 will be real, but when n is even, then x0 and x of n by 2 both will be real for sure shot, but other values can also be real in some cases, but here it is sure shot that x0 will be real and x0 and xn by 2 will be real in case of n is even. So this you can easily see, and if in any question it has been asked, then you can easily solve it. Okay, so I have to just remove it, or I will just uh, reduce the size of this. Okay, because I have only one page for one question. Okay, so I have reduced the size. Now let's do the question. It's a very simple question. So xn is real, 12-point DFT. So since xn is real, xk will be conjugate symmetric. Okay, x of minus k conjugate or x of n minus k conjugate, or I can say that x of n minus k. I will replace n by 12 here. Okay, so 12 minus k is equals to xk conjugate. So from here I can say that if k is 1, so x11 equals to x1 conjugate, that will be equal to minus 1 minus 2j because x1 is given here. Similarly x10 will be x2 conjugate, that is 2 minus 3j because the value is given here. X9 will be x3 conjugate, that is 1 plus 4j given here. X8 will be x4 conjugate, that is minus 2 minus 2j. X7 will be x5 conjugate, that is 3 minus j. Okay, so we now know all the values of xk because 0, 1, 2, 3, 4 and 5, 6 are given to me. 7, 8, 9, 10, 11 I have already found. So this finishes my question number 1. Now let's move to question number 2. So the DFT of real sequence is this. So we have to find value of a, b and c. So it's the same similar kind of question. 1 a minus 1 b 0 minus 2j. Okay, so this is your xk. And from here we can see that since it is 0 1, okay, I will change the color. So it is 0 1 2 3 4 5 6 7. So we can say that it's a 8-point DFT, because n goes from the values are from 0 to 7, that is there are 8 values, so it's a 8-point DFT. So since it is given that the signal was real, so I can say that xk is equals to x8 minus k conjugate, or I can say that x of 1 when k is equal to 1 is equal to x of 7 conjugate. And since we know x of 7, so we can easily find x of 1, so this implies a is equal to minus 1 minus j. Similarly, x of 3 will be equal to x of 5 conjugate, and we know x of 5 is minus 2. This implies b is equal to 2j. Now x of 6 is equals to x of 2 conjugate, that is this implies c is equals to minus 1, because this and x of 2 is minus 1. Okay, so this solves the question number 2. So these kind of questions you can easily find in the previous year also. So I have tried to keep the questions that I am solving similar to that of the previous year questions, so that you can have the feel of the previous year questions also. Now it is given that xn is equals to this, x0 is given, x4 is given, you have to find a and b. First of all, it is 0 1 2 3 4 5 6 7. So minimum value of n, since length of xn is 8, so minimum value of n is greater than equal to 8. So let us take n is equal to 8. Okay, so since we can see that xn is real, we have to find a and b. So xk is actually equal to, or even if it's not equal to, it's not given it's real, so then also the formula is valid. The formula of the DFT is this. Okay, so n equals to 0 to 7 xn e to the power minus j 2 pi by 8 nk. Okay, so this is your xk. Now we can see that x0 is equal to summation n equals to 0 to 7 xn, so sum of all the values. So I can say that this is given equals to 20. So I can say that a plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus b is equal to 20, or I can say that a plus b plus 27 is equal to 20. So this is your equation number 1. Now it is given that x4, that is equal to, if we put k equal to 4 in the equation, so it will be minus j pi n. Okay, so k equal to 4 in this equation will give me this. So that is equals to summation n equals to 0 to 7 xn minus 1 to power n. So this is equals to 0. Okay, so easily I can say that a minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus b is equal to 0. So a minus b plus 3 is equal to 0. So this is equation number 1. This is equation number 2. And from these two equations I can easily get that a is equal to minus 5 and b is equal to minus 2. Okay, so this is the solution to this question number 3. Now let's move on to next question, that is question number 4. Okay, so it is given that it is given that a real sequence has DFT equal to 1, A minus 1, B minus 7 minus 2J, C minus 1 plus J. Okay, and so I can say that this is at 0, 1, 2, 3, 4, 5, 6, 7. So it's a 8-point DFT, right? Since it's a 8-point DFT and it's a real signal, so I can say that xk is equals to x8 minus k conjugate, or I can say that x1 is equals to x7 conjugate, that is a is equal to minus 1 minus j. Similarly, x3 is equals to x5 conjugate, that is, this implies b is equals to 2j. Similarly, x6 is equals to x2 conjugate, this implies c is equals to minus 1. Okay, now from Parseval's theorem, since we know that x conjugate x cap n has DFT xk. Okay, now single period of x cap n is equal to xn, we know that, and thus from n equals to 0 to capital N minus 1, xn square is equal to 1 upon n summation xk square k equals to 0 to n minus 1. This is the Parseval's theorem that we know. Okay, so since we know that xn is non-periodic signal which become periodic after doing DFT. Okay, so x cap n is periodic signal, xn is a non-periodic signal, and xn is single period of x cap n. Okay, so this gives me the energy of x, and that is equals to 1 upon 8 summation 0 to 7. Okay, so we have to find the energy of the signal. So this is the formula of energy of signal, that is modulus of square of all the values of xk divided by 8. So that is equals to 1 square plus mod of a square plus 1 square plus mod of b square plus 7 square plus 2j mod square minus 2j mod square plus c mod square. I will have to add a page here. Okay, mod c square plus mod of 1 minus 1 plus j square bracket. We know the value of a, b and c, so the result will be 1 upon 8, 1 plus, we know the value of a, that is minus 1 minus j, so mod square will be 2 plus 1, b equals to 2j, the mod square will be 4, 49 minus 2j mod square will be 4, c is minus 1, so mod square is 1, minus 1 plus j mod square will be 2. So now let's move on to the next question. That will be the question number 5. Okay, so question number 5. So it's given that length of the sequence is 6, that is xn is given to us 1 minus 2 3 0 minus 1 and 1. Okay, so this is given to us. Xk is 6-point DFT, so it is 0 to 5, n equals to 0 to 5 xn e to the minus j 2 pi by 6 nk. Okay, so we can say that x0 when k equal to 0 in this equation number 1, so that will be easily equal to n equals to 0 to 5 summation on xn, right? So it is simply the summation of all the values of xn, so it will be 1 minus 2 plus 3 plus 0 minus 1 plus 1, so that is equal to 2. right? Now second, x3. So if you put k equal to 3 in equation number 1, then we will get n equal to 0 to 5 xn e to the power minus j pi. When k equal to 3, it will be pi n. Okay, so that will be actually equal to n equal to 0 to 5 xn minus 1 to the power n. So that is actually equal to x0 into 1 plus x1 into minus 1 plus x2 into 1 plus x3 into minus 1 x4 into 1 plus x5 into minus 1. Okay, so easily we can see that it will be 1 plus 2 plus 3 plus 0 minus 1 plus 1. So the answer will be, sorry, minus 1 minus 1, that will be there. So the answer will be 4. Okay, so here I have to just add a page, okay, for the further solution. Now the third part. So in the third part, you can see that we have to find summation k equal to 0 to 5 xk. Now since xn equals to 1 upon n, summation k equal to 0 to n minus 1 xk e to the power plus j 2 pi by n nk. So we can say that in this equation, for example, this is equation number 2. In this equation number 2, if I put n equal to 0, so x0 will be 1 upon 5, sorry, 1 upon 6, because n is 6 now, 0 to 5 xk. So the answer, that is summation 0 to 5 xk equals to 6 times x0, and we know that x0 is 1, so it is 6 into 1, so 6 is the answer, right? Now the fourth, we have to find k equal to 0 to 5 mod of xk whole square. Now as we know that the Parseval's theorem states that 1 upon 5, sorry, n is 6 now. So 1 upon 6 k equal to 0 to 5 mod of xk square is equal to summation xn square n equals to 0 to 5. So summation k equal to 0 to 5 is equals to 6 summation okay, so that will be equal to 6 multiplied by the sum of values, so 1 plus 4 plus 9 plus 0 plus 1 plus 1, so that is actually equal to 96. So 96 is the answer, right? So this finishes the question number 5. Let's look at question number 7. So in this question it is given that xk is a DFT of the signal, that is 4, minus 2, 0 and j2. Okay, so we have to find the DFT of xn minus 2. DFT of xn minus 2. Now we know that in time shifting property the effect goes with the same sign. So xn minus 2 will have DFT, that is xk e to power minus j 2 multiplied by 2 pi by, and since it's a 4-point DFT only, because there are 4 points, 4 values in xk, so it's a 4-point DFT. Okay, so k only here. So xk e to power minus j pi k. So that's your the DFT of xn minus 2. Or I can say that it is xk minus 1 to power k. Okay, so DFT will be 4 because k equal to 0 here, and here we have k equal to 1. K equal to 1, x1 is minus j2, and minus 1 to power 1 will be minus 1, so answer will be j2. At k equal to 2 it is 0, so no changes. At k equal to 3 it is j2, x3 is j2, and minus 1 to power 3 is minus 1, so minus j2, xn minus 2. Okay, second, DFT of x minus n. Now since we know that x minus n has DFT equals to x minus k or x 4 minus k, because it's xn minus k where capital N is 4 here. So DFT will be x4 minus k. So when k is 0 it is equal to x4, and so I will write like this: x4. When k is 1 it is x3, x2, x1. Okay, okay. Now since xk is periodic with period 4, so x4 will be equal to x0, that is 4, x3 we know that is j2, x2 we know that is 0, and x1 we know that is minus 2j. So this is the answer. Simple question. I will have to add a page here. Okay, now third part. DFT of x conjugate n. We know that x conjugate n has DFT equal to x conjugate minus k or x conjugate 4 minus k. Okay, so DFT will be equal to x conjugate 4, x conjugate 3, because here k equals to 0, here we have k equal to 1, here we have k equal to 2, and here we have k equal to 3, so it is 1 conjugate. Okay, and we know the value of x4 as given in the question. X4 is equal to 4, so 4 conjugate is 4, x3 is j2 and conjugate will be minus 2j, x2 is 0, so conjugate is also 0, x1 is minus 2j, so conjugate is 2j. So this is the result. Okay, so this is the DFT of x conjugate n on the fourth part. We have to find DFT of x square n, that is xn multiplied by xn. So xn multiplied by xn will be the circular convolution of the DFT of the signal. So circular convolution of the two signals. Okay, so the circular convolution formula is 1 upon n also. 1 upon n circular convolution of the DFT of the two signals. So 1 upon 6 circular convolution formula is n going from 0 to 5. Sorry, here DFT is of 4 point. So n is 4, it is 3 xm x k minus m. So let us say that the DFT is yk, that is equal to this. Okay, right? Now again I have to add a page here, so I think I will add 2 pages. Now from here we can see that y0. Okay, you can see the method of circular convolution from the video given in the channel or named circular convolution. Okay, so here I'm just going by the formula, but there I have explained 2 or 3 methods for solving the circular convolution. So y0 will be 1 upon 4 summation m equal to 0 to 3 xm x minus m. Okay, so y0 will be 1 upon 4 x0 into x0 x1 into x minus 1 x2 into x minus 2 s3 into x minus 3. So this finishes the okay. Now as we know that okay, this is your xk, right? Xk has values 4, 2j, 0 and sorry minus 2j, I'm just drawing it, okay, minus 2j, 0 and 2j. Okay, so since it is periodic, so it will be like 4 minus 2j, 0, 2j, right? So it is 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4. Okay, so now I can easily get multiply all the values. So I can see that y0 is equals to 1 upon 4 x0 multiplied by x0, that is 16, plus x1 multiplied by x minus 1. So x1 is minus 2j, x minus 1 is 2j, x2 and x minus 2 both are 0, x3 and x minus 3 is 2j multiplied by minus 2j. So that is 1 upon 4, 16. So j into j, j square and minus 1. So j square is minus 1 is plus 1. So it's 4 plus 0 plus 4. So 24 upon 4, that is 6. So y0 equals to 6. Similarly, y1, y2 and y3 can be calculated easily using the formula, or you can go through the method given in the video of circular convolution and you will get y0, yk, that is the circular convolution. The result will be 6 minus 4j, 0 and 4j. Okay, and we know that when two periodic signals of period 4 are circularly convolved, the result is also periodic with period 4 only. Okay, so now we will do the 5th part of the question, that is we have to find the DFT of xn circularly convolved xn. Now as we know that when two signals are circularly convolved, their DFT gets multiplied. So the DFT of this will be xk multiplied by xk. So that will be 16 minus 4, 0, minus 4. Okay, you just have to multiply xk with xk, that is x0 into x0 will give us the first term, x1 into x1 will give us the second term, and so on. Now last part, that is signal energy. Okay, now as we know the Parseval's theorem, Okay, so mod of xk square, so that will be 1 upon 4, and x0 mod square will be 16, x1 mod square will be 4, then 0, then 4, so that is 6. Okay, so this was question number 7, a very good question, a very lengthy question, long question. Now let's look at question number 8. It is given that xn is 1 2 1 0. Now we have to find inverse DFT of xk minus 1. Now if xk was the DFT of xn, then xk minus 1 will correspond to, the effect goes with the opposite sign, we know that, right? So plus j 2 pi by n into 1 into n, where capital N is 4, right? Because it's a 4-point DFT, right? So xk minus 1 corresponds to x0 multiplied by e to the power j0, x1 multiplied by e to the power j 2 pi by 4, x2 multiplied by e to the power j 4 pi by 4, x3 multiplied by e to the power j 6 pi by 4. Okay, so this will be the result. You know x0 is 1, so it is 1. x1 is 2, so it is 2 e to the power j pi by 2. x2 is 1, so e to the power j pi, and the fourth term is 0. So 1 2j minus 1 0. So that's the answer. Okay, so the second one, inverse DFT of xk circularly convolved xk. Now as we know that 1 upon n xk circularly convolved xk corresponds to the product in time domain, so xn multiplied by xn. So I can say that xk circularly convolved xk will be 4 times xn multiplied by xn. So easily we can get the result. So that is 4 multiplied by 1, 4 1 0. It is 4 16 4 0. Okay. Now we have to find the IDFT of xk convolved xk multiplied by xk. So that is, we have to find the signal which has DFT equals to xk multiplied by xk. So we know that circular convolution in time domain will give us this property. So we have to circularly convolve these two signals, that is xn with xn. So let us say yn is equal to circular convolution xn okay. So we can see that y0 is equals to x0 into x0, x1 into x minus 1, x2 into x minus 2, x3 into x minus 3. Similarly y1, y2, y3 you can write the formulas and you can get that yn, easily you can solve and get that yn is equals to 2 4 6 4. That is The result is 2464. Fourth, we have to find signal energy. Now we know signal energy is mod of xn whole square summation n equals to 0 to 3. So the result is x0 mod square, that is 1, x1 mod square, that is 4, x2 mod square, that is 1, and 0. So it is 6. So 6 is the answer. Okay, so we have solved 8 questions here, and for previous year you can go through the previous year lecture series available on the channel. So thank you.